Last week I noticed strange new branches in my GitHub repositories. As it turns out, GitHub automatically scans your dependencies for security vulnerabilities, and it found one in JUnit, so it decided to bump from 4.12 to 4.13.1. So maybe let's quickly look at the vulnerability. Here we can see a temporary folder on Unix-like systems does not limit access to created files. And if we look at the example, I quickly concluded that rule temporary folder, I've never used this, so this probably doesn't apply to me. Okay, but just to be sure, here's a nice checklist that we can check. Do the JUnit tests write sensitive information like API keys or passwords into the temporary folder? I don't do that. And do the JUnit tests ever execute in an environment where the operating system has other untrusted users? I don't do that either. Okay, so this definitely doesn't apply to me, and I guess that's why the severity is ranked as low. Okay, but it got me thinking, wait a minute, 4.13? I always thought that 4.12 was the last JUnit 4 version, so I decided to take a look at Maven Central. Okay, so here you can see 4.12 is indeed still by far the most popular download. It was released almost 6 years ago, but then 5 years later, 4.13 was released. I never noticed until now, with about 10% of the downloads. Okay, so 5 years in the making. So 4.13 should be full of lots of cool features, right? So let's look at the release notes for 4.13. So summary of changes in version 4.13. As you can see by the scroll bar, it's very short, so the list of changes is indeed very long. And my favorite change is this one. AssertThrows is added. So the assert class now includes methods that can assert that a given function call results in a particular type of exception being thrown. So this should deprecate the old annotation-based approaches, or even worse, the try, fail, empty catch block idiom, which you may have seen in the dark ages. Okay, so why don't we take some old 4.12 code and refactor it to 4.13 with the method assertThrows. Our first example is rather simple. We have a test method called picImaginary_beeper with only a single method call in its body, and it's annotated with test with an annotation parameter ExpectedException class. So we expect that somewhere in the body the cell_is_empty exception is thrown. So since there's only a single method call, picBeeper will probably throw cell_is_empty. Okay, so how do we rewrite this with a new method? We simply write assertThrows, then the ExpectedException type. Then we open the body and move the old method body into the assertThrows body. And then we can get rid of the annotation parameter. Okay, so in this case, we don't really gain anything new because this example was so simple, but in the next example, it'll get more interesting. The interesting point about the second test method is that now it contains 2 method calls in its body, and I, as an author of the test, know the first one doesn't throw an exception and the second one does throw an exception, but the code doesn't express that, and I would like to make it clearer. Okay, so first of all, let's get rid of the annotation parameter up here, and then let's use assertThrows with the exception, open the body, move this line into the body, and now we have improved the code, right? Any maintainer can now see the first line isn't supposed to throw any exceptions, and the second line is supposed to throw cell_is_full_exception. So assertThrows gives you finer control on where exactly in your method bodies the exceptions are supposed to be thrown. The third example demonstrates the old rule-based approach to expected exceptions. So what exactly is going on here? We have a private helper method which creates a lexer and then calls a method on that lexer, and that method call is supposed to throw an exception of type diagnostic where the diagnostic exception message contains a given substring. Okay, so let's start here. How do we replace thrown expect? We do that with the assertThrows, give it our expected exception, then open the body and move the offending line into the body. Okay, so now we can get rid of thrown expect. What about this guy, thrown expect message? How do we get at the message of the exception? Or first of all, how do we get at the exception? As it turns out, assertThrows catches the thrown exception and then returns it as a result. So we can simply assign it to some variable, and in case you're confused about the type, it is the exception type that was thrown and then called. Okay, cool. Now, how do we check that message? We can simply assert that the diagnostic message contains the given substring. Okay, and now we don't need thrown expect message anymore, and of course now we can replace or remove all the stuff above here. Okay, so this is how you replace the rule expected exception with assertThrows and then further assertions on the exception that was thrown. And since it was so much fun, let's do it again on a slightly different example. Let's start by removing stuff. So get rid of the rules, get rid of these two method calls, and then let's say assertThrows, the expected exception, and then move the offending line into the body. Then we need the result of assertThrows, so we can assert that the diagnostic message contains the given substring. Okay, that's it. So I find this quite much more readable than the old rule-based approach. So what about you? Are you still on 4.12? Will you update to 4.13? Or have you long updated to JUnit 5 3 years ago? Let me know in the comment section below.